Line following is cool, but what happens when your robot needs to do more, like detect different colors and respond based on how many times it's seen them? For example, keep going the first time it sees yellow, but turn 90 degrees right when it sees yellow again. That's where state machines come into the picture. Welcome back to Learn as You Explore, your go-to place for mBot2 tutorials. If you are new here, I'm a robotics software engineer who loves helping students learn robotics and supporting teachers who teach it. In this video, we're going to break down what a state machine is and build a cool project using it. The project in this video builds on our advanced line follower project from earlier. Check out the advanced line following video if you haven't already done so. The link is in the description. If you're excited to grab the mBot2 or any accessories, check out the links in the description. I've added Amazon and mBlock links. If you use the links, I may earn a commission at no extra cost to you. Thanks for supporting the channel. So what is a state machine? Let's start with a simple example. Say you want to watch a movie and snack on some popcorn. Here's how your brain might break that down step by step. First, making popcorn. Start the popcorn maker and wait. Once the popcorn is done, take the popcorn out. Next step, go to the living room. Carry the popcorn and walk to the movie room. Once you're near the couch, sit down. Next step, watch the movie. Press play. When it ends, turn off the TV. Even though this feels automatic to you, it's actually a clear algorithm, a sequence of steps where you're always in one state at a time, doing a task until it is done, then moving on to the next state. This model is exactly what a state machine is. A system where you're in one state at a time. In each state, you perform some repeating action until a completion condition is met. Then you do a few one-time actions and then transition to the next state. This is a powerful way to think about robotics programming because robots naturally fit into this framework. Robots repeatedly perform a set of actions, wait for sensor inputs, and then move on to the next task. Let's now build a project using this idea. We want the mBot2 to follow a line. When it sees yellow, keep following the line. When it sees blue, turn around 180 degrees. This means that the robot is again headed back to the yellow patch. When it sees yellow again for the second time, turn right 90 degrees and stop. Let's break this down into states. We'll define 3 states: searching for yellow, searching for blue, and searching for yellow 2. The searching for yellow 2 state simply refers to the second yellow detection by the robot. In each state, we have 3 things to define: the repeating action, the completion condition, and the one-time action, followed by the transition to the next state. While we're in the searching for yellow state, the repeating action is simply line following. That is, we want to keep following the line until we detect yellow. The completion condition is yellow detected, and once we detect yellow, the one-time action we'll perform here is to simply stop and wait for 1 second, and then transition to the searching for blue state. Now that we've seen how to define the first state, take some time to pause the video here and write down what you think the repeating action, completion condition, and one-time action for the searching for blue state should be. Feel free to pause the video now and come back when you've given it some thought. Okay, let's continue. In the searching for blue state, our repeating action is once again line following. Our completion condition is blue detected, and our one-time action is stop and wait for 1 second and then turn around 180 degrees. Then we'll transition to the searching for yellow 2 state. Great job if you got this right. In the searching for yellow 2 state, our repeating action is once again line following. The completion condition is yellow detected, and our one-time action is stop and wait for 1 second and then turn 90 degrees to the right. After this, we'll end the loop and stop the program. Now that we have all our states defined, let's go to mblock and implement this in our block program. If you've made it this far in the video, please consider giving the video a thumbs up by clicking the like button and subscribe to the channel if you haven't already done so. It really helps keep the channel going. Open mblock and open your advanced line follower block program. You can find this in one of my previous tutorials. I've added links to that video on the top right here as well as in the description. Let's first save this program as a new one. I'm going to call this state machine intro and say OK. Since we're going to be repeating the line follow portion in every state, let's make it modular. We'll define a new block and call it doLineFollow and say OK here. We now have a space to define the doLineFollow block. Let's move our main logic inside the repeat until loop to the doLineFollow block. In addition, we'll also move the set base power and set KP blocks to the beginning of the doLineFollow block. Now that we have this doLineFollow definition, the next time we want to perform line following, we can simply go to My Blocks and use the doLineFollow block here. We also need to keep track of the current state of the system. So let's create a new variable and call it state. Say OK. Referring to the state definitions, the first state we want to be in is searching for yellow. So prior to the loop, let's set the state variable to an initial value of searching for yellow. Within the loop, let's add an if-then-else block. And for the condition, we want to check if the state is searching for yellow. So let's grab an equals operator. The first operand is going to be the variable state, and the second operand is going to be searching for yellow. From our requirements, what is the action that we want to do repeatedly within this state? It is just line following. So let's use the doLineFollow block that we just defined here. Now that we have our state and the repeated action defined, let's detect the completion condition next. We will use an if block for the completion condition. In the searching for yellow state, the completion condition is true when we have detected yellow. We can do this using the quad RGB sensor's L1R1 status block. We define our completion condition to be either L1 or R1 should detect yellow. So we can set the detection to yellow. For the status, we want it to be either 0, 1, 1, 0, or 1, 1. That is either the decimal value 1, 2, or 3. Because in each of these cases, at least one of the two sensors have detected yellow. Thinking of this in another way, we can also say that as long as the yellow status value is not 0, we have detected yellow. To implement this, let's leave the status value as 0 and invert this logic by using a NOT operator. So drag the NOT operator block and insert the L1R1 status block into the NOT operator. We'll then move the NOT operator block entirely into the if condition. Let's move things around to keep it clean. Once the completion condition has been detected, we want to perform the set of one-time actions prior to transitioning to the next state. In this case, our one-time actions are stop the motors and wait for 1 second. We can stop the motors by using the stop encoder motor all block, and we can wait for 1 second by going to the control block category and using the wait 1 second block. Finally, we will transition to the next state by setting the state variable to searching for blue. And that completes the first state. Don't forget to save your program to retain your hard work. We'll continue the rest of the program in the next video, implementing the other two states and testing it live on the mBot2. Remember to subscribe so you don't miss it. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.